This is Mrs. Boots, and we're going to work through our modeling practice problems. The first 4 practice problems were word problems that we take the information to create our model. You really didn't even need to have the calculator. You just had to use your head a little bit. So let's look at this. In number 1, we have a fable about a man from India who invented a game of chess as a gift for this king. The king was so pleased with the game he offered to grant the man any request within reason. Then the man asked for 1 grain of wheat to be placed on the first square of the chessboard, 2 on the second square, 4 on the third, 8 on the fourth, doubling the number of grains of wheat each time until all 64 squares on the board had been used. The king, thinking this was a small request, agreed. The chessboard has 64 squares. How many grains of wheat did the king have to place on the 64th square? So we've already noticed that he's doubling the number each time. So this would be the square and the number of wheat. Okay? So on the 0 square, technically the first, there's 1. First square, there's 2. Second, there's 4. Right? Third is going to be what? 8. The next one, there's 16. Next one, there's 32. Next one's what? 64. Then we have 128. We keep doubling it, so I'm going to put dot, dot, dot until we reach, because we started with 0, we would only go to 63. So if you keep doubling it in the calculator, it gets kind of crazy, but it's 9.2 E18. So what does E18 mean? That means that I'm taking that decimal and I'm moving it 18 places to the right. So that's like 9.2 billion or something crazy like that. So the equation, all I'm doing is doubling it. So that's 2 to the x. The doubling tells you the base. My domain, there's only 64 squares on the chessboard, but we started at 0. So we're going from 0 to 63. We're going to include all 64 squares. The range, well, there's 1 grain on the first square and then 9.2 E18 on the last square. So if we were to graph this, at 0 we would be at 1. At 1 we're at 2. At 2 we're at 4, right? 4 is 8. And then we go up to 16. That's about as far as we get on our graph. Now, do we have anything in the negative quadrant? No, because we don't have negative places on our chessboard. So we would stop right here at 0, 1. We wouldn't go any further than that. Number 2, we have 50 grams of radium stored. The half-life of radium is 1620 years. How many grams of radium will remain after 4,860 years? Okay, so we're going to label the first column cycle. That means how many times has it passed. So you've at 0, when you get to the first 1620, right, it's cut in half. So I started in 50. 50 grams is my Y. My next one would be 25. Cut 25 in half, I get 12.5. Cut that in half, I get 6.25. Okay, let me fill in my x values real quick. So each time I'm cutting it in half. That's all we're doing, is just cutting it in half. So my equation would be y equals, start with the 50, cut it in half. Now I could have put 0.5 or 1/2, either way. Remember, it's x, or time, divided by the d, which was 1620. Okay? So my domain, in this case, we're just going from 0 to 4,860. My range goes from 0 to 50, assuming I can get to 0. Can I get to 0? Not really. So that needs to be a parenthesis with that 0. Okay. Now let's look at the graph. I'm starting at 50. You can decide where 50 is going to be. I'm going to put it at 10, so I'm counting it by 5s. Right? Half that, we got 25. Half that, 12.5. Half that was 6.25. And you see it goes down pretty quick. Remember, you're not including anything on the negative side of the x because we can't go back in time. Number 3. We have 70 grams of radium stored and the half-life compounded is 53 years. So in the x column, we're counting by increments of 53. Each one gets to the next number. We're going to go and see what happens at 848 years from now. So we're cutting it in half each time. So half of 70 is 35. Half it again, 17.5. Half it again, 8.75. Half again, 4.375. It's getting small. Half again, 2.1875. Now let's look at the equation. Y equals, I started with how much? 70. And we're taking half each time. And how many years apart is it? 53. So it's x divided by 53. So my domain is going from 0 to 848 for this particular problem. We could see how many cycles it takes to get to 0. Obviously, I'm getting to 0, and my highest amount was 70. So I'm going to start with 70 on the x-axis. Sorry, the y-axis. Cut it in half. Cut it in half. Cut it in half. Cut it in half, all the way down. We cut it in half each time. So we have a very steep decay curve that comes in and gets really close to 0. Number 4. If your parents agree to pay you a penny today and double it every day for 10 days. Okay, so I'm only going to get them to do this for 10 days. That's a bummer. Because it would be great to see how much money we'd have in a month. In fact, I challenge you to figure that out. But on the first day, we're going to get a cent. 1 penny. How much would we get the next day? Well, that's easy. 2 pennies. Double it, 4. Double, 8. Double, 16. You get the picture. Double, 32. Double, 64. Double is 128. Double that, 256. Double that, 512. Okay? Now let's look at the equation. What did we start with? We started with 1 penny, 0.01. What did we do? We doubled it every day, so it's just an x. For this problem, my domain goes from 0 to 10. My range is what? 1 penny to 512 pennies. Now, in all honesty, if you can get your parents to do this for a 30-day period, you will be independently wealthy and your parents will be in a lot of debt. But that's okay. So, let's just graph it. So we start with 1 cent. We go to 2. We go to 4. We go to 8. And you get the picture. Goes up to 16. There we go. And by the way, at 15 days, you would get $327.68. See if you can figure out what it is at 20, 25, and 30 days. Now we have some straight models that we can just plug in the calculator and get the equations, the domain, and the range. So let's look at it. First, let's figure out if it's a growth or decay. So in problem 1, all my numbers are increasing for x and they're increasing for y. This means that it's a growth. As x is increasing, y is increasing. Both going in the same direction. My equation, I would go to Stat, Edit, plug these numbers into the table. X goes in L1, y goes in L2. Then go Stat, Calc, and scroll down to EXP Reg. Remember exponential regression. So when I do that, I get for my equation y equals 0.125 times 2 to the x. I'm not really surprised because 0.125 is my 0 value, so it should be the a. My base is 2 because it's doubling. That makes sense to me because I see that it's doubling to get to the next number. Now let's look at domain. My domain is from 0 to 5. I'm including the 0 and the 5. My range is from 0.125 to 4. We're just using the numbers in the table. You cannot go to infinity because you don't know if they destroyed it or what happened. Let's look at number 2. Actually, that's number 3. I'm going across instead of down. So let's look at number 3. Which direction am I going? Is it a growth or decay? Well, as x increases, y is increasing. That makes it a growth. All right. So I go to Stat, Edit, put my numbers in. Notice the x's are the same on all of these, so you can leave those alone and just change your y's. Then go to Stat, Calc, and select EXP Reg. The equation is y equals 0.5 parenthesis 3 to the x power. Well, that makes sense. 0.5 is my first value, so it should be my a. Double check it. Multiply each of these numbers. 0.5 times 3, 1.5 times 3. Do you get the next number in the table? Good job. Now let's do the domain. The easy part is the domain for everything on these is 0 to 5 because that's what's in the table. Your range goes from what? 0.5 to 121.5. Now let's do number 2 and number 4. Number 2. Put the numbers in the calculator into Stat Edit. Now go to Stat Calc, scroll down to EXP Reg. So I notice as I'm putting my numbers in, as my x is increasing, my y's are increasing. So that's a growth. So I'm expecting a whole number for my base. What am I expecting for the number in front? That's right, a 6. So now go to Stat Calc and run your equation. We get y equals 2 to the x plus 6. Do I have my 6? Yes, I do. I see it's 2 to the x. Well, that's awesome because as you look, there's something in there doubling. Okay, domain. Well, I already gave you that one for all the problems. Told you it was 0 to 5. Then I put the lowest number in my y and the highest number every single time. That's going to be my range. So in this case, it's 6 to 37. Number 4. As x is increasing, what is y doing? It's decreasing. So that means it's a decay. All right. So what are we expecting? I'm expecting to have a 57 in my equation. Let's run it. Stat edit, enter in the values for y in the L2 column. Stat calc, exponential regression. Equation is y equals 57, parenthesis, 0.25 to the x. Aha! So I do have my 57, and I'm essentially dividing by 4 each time. My domain is still from 0 to 5, and my range is what? Small number first, 0.056 to 57. Don't get them backwards. Number 5 and 6. Number 5. As x increases, what is y doing? It's decreasing. That means I have a decay. So I'm expecting a fraction for my base. I'm also expecting that 64 to be in the equation because it is the y value when x is 0. So I go to Stat Edit. I enter the y values into L2. X's are in L1. I go to Stat Calc and I do EXP reg. Okay, the equation is y equals 64, parenthesis, 0.5 to the x power. Is that what we expected? Yes. And you know, we could have figured that out by hand just by cutting each one in half. You can see the pattern. So what's the domain? We went from 0 to 5. And what's the range? It goes from 2 to 64. Remember, you always go low to high. So let's see if we can just figure it out on number 6 without using the calculator. What do we notice? As x is increasing, y is decreasing. So we know it's a decay. What value should be in the equation? That's right, 100. So I'm going to have y equals 100, parentheses to the x. What goes in the parentheses? Well, if I'm going from 100 to 50, I cut it in half. Cut it in half, cut it in half. So I'm expecting a 0.5 in the parentheses. Let's check it. Go to the calculator and in Stat, Edit, enter your y values into the calculator and then run the exponential reg. And let's see if we get what we thought we would. And the answer is yes, we did. Now let's do our domain. We go from 0 to 5, and our range, remember, a small number, so that's 3.125, to the largest number, 100. Now we have some inequalities. The reason why we put the inequalities with the modeling is at this point you cannot solve them algebraically. We haven't taught you how to. Maybe you're smart enough to figure it out. But in any case, we're going to show you how to solve these using a table. Remember, you could also use a graph. So I could use a graph, a table, or algebra. We're going to show you the table. So for number 1, I have 3 to the x plus 1 power, and I want to know where it's greater than 9. So I'm going to plug the 3 to the x plus 1 part into y1. And then I'm going to do a second graph to go look at my table. I'm going to write some of those table values down. So I see at -1, the y value is 1. At 0, I have 3. At 1, I have 9. And at 2, I have 27. Now, how do you know which values to write down? Well, you have to pay attention to what you were looking for to begin with. We were looking for a 9. I see a 9 in my table. So I'm going to write a couple numbers above that 9 and a couple numbers below it. What did we want to know? We wanted to know where it is greater than 9. So I'm looking for all my y's greater than 9. Well, that means I'm going this direction in my table to get the greater values. So my domain for that would be in the corresponding area. So the domain for this, where do I find it greater than 9? From 1 to infinity. Infinity gets a parenthesis. Does the inequality symbol have an equal sign? No. So the 1 also gets a parenthesis. This would be my solution for that inequality. Let's look at number 2. Again, I plug in the left-hand side of the equation into y equals. That way, I can find the table. We're looking for the value of what? 253 in the table. So I start at 0 and I see 200. 1 is 206. So I'm going to scroll down. I put a ... to indicate that I'm scrolling down. 7 is at 245.9. That's pretty close. And 8 is at 253.35. So it starts at 8. I'm going to circle this in my table. Now, what am I looking for? Well, the inequality symbol said greater than. Well, at 7, it's less than 253. So I'm going greater, which means I have to go up. So my answer is going to be from 8 to infinity. The 8 gets a parenthesis because my inequality symbol does not have an equal sign. Number 3, 4 to the x minus 2 is less than 64. Plug in the left-hand side into y equals. Now let's look at some numbers. At 2, I notice my y value is 1. 3 is 4. 4 is 16. I'm getting closer. 5 is 64. So I found my 64 in the table. Now what do we want to know? Look at the inequality symbol. Notice the equality symbol is less than. I want all the y's that are less than 64. That means I'm going backwards. Less than 64. So I want from 5 going to where? Negative infinity. Well, that means what? I start at negative infinity and go to 5. Now, do I put a parenthesis or a bracket? Look at the symbol. The symbol is a not equal. It's just a less than or greater than. I get a parenthesis. If it has the equal, I get a bracket. Okay. Number 4. 1/2 to the 3x minus 1 power. Take the left side and put it into y equals. Let's look at our table and write down some values. So at negative 3, it's 1024. Negative 2 is 28. Well, that's the value in my equation. But I'm going to keep going just so I make sure. Negative 1 is 16. 0 is 2. We want to know what? We want to know where it is less than the 128. So look at the y's. Where is it decreasing or less than 128? That would be as it goes what? To positive infinity. Okay? So I would start at negative 2, the x value, and go to positive infinity. They're both going to get parentheses because the inequality symbol does not have an equal sign. It's just a parenthesis. Number 5. 10 to the x plus 500 is greater than. Okay, so y equals. Let's look at the table, and I'm looking for the value of what? 1500. So I see at 0, it's at 501. 1 is 510. Okay. 2 is 600. That's increasing. 3, 1500. Okay, I found my 1500. Let's do one more. At 4, it's what? 10,500. I want to know which direction. greater than. So where are my y's bigger than 1500? That's easy. They're bigger as I go towards the positive infinity. So I'm going to start at 3, the x value, and go to positive infinity. Because there's no equals, it just has a parenthesis. Now let's look at number 6. 1,500 and 1.25 to the x. There's my y equals. What value am I looking for in the table? 768. Yeah, it's a weird one, but that's okay. Life is weird. So I'm looking through my table and I see at -4, I'm at 614. -3 is my 768. I care about that value. Let's look at -2. That's at 960 and 0's at 1500. Now which direction do we want to go? We want greater. So I want all the numbers bigger than 768. That's going to go towards positive infinity. But where did we start? We started at -3 and went to the positive infinity. Both get parentheses because there's not an equal to. Number 7, 1/2 to the 2x plus 5. Power. That's what I'm putting into y equals. Now let's look at the table. What are we looking for in the table? 32. So in my table, wow, I need to go to the negatives. At -6, I have 128. -5, well, there's my 32. Make sure you got a note on that. -4 is 8. -3 is 2. What's the inequality symbol? Greater than. Where are my y's bigger or greater than 32? Well, that's going towards negative infinity. So, I'm going to start at which x value? The one for 32, which is 5, -5. I'm going to negative infinity? No, that's not how we write it. Remember, we have to go from negative infinity to the -5. So make sure you've got it in the right order. Number 8, 5 to the 3x minus 7 plus 2. Make sure that plus 2 is not in the exponent. I'm looking for what number in my table? 27. Okay, let's look at it. At -1, I've got 2. Well, let's skip down a little bit. At 2, I've got 2.2. 3 is 27. That's my number. Okay, let's do one more. 4 is, wow, 3,127. So which way am I looking? Greater than. I want to know where it's bigger than 27. Well, that's going to positive infinity. So what is the domain for that? I start at my x value, which was 3, and I'm going to positive infinity. They both get parentheses because the inequality symbol did not have an equal to.